Hi, I'm QE. I'm application engineer from Kent Hill Metrology, and welcome to our showroom here in Shah Alam. Okay, today I'm going to show you how to measure the plastic part. And here you can see is our Vitomax M300 from Waygate Technologies. And let's look inside of the machine. What we have here is our dual tube configuration. And Vitomax M comes with the option of dual tube, which you can see here is our 180 kV nano focus tube, and here is the 300 kV micro focus tube. And on the middle part is our precision rotation unit with air bearing that can rotate 360 degrees to scan the samples. And on the left side is our 16-inch times 16-inch dynamic 41-200. That is our high resolution 200 micron detector with superior image quality. Okay, so let me show you this plastic parts. And now I will just put these samples in the machine. And I'll close the door. Here is our 27-inch monitor where you can see much detail. And now I'll turn on the X-ray. Okay, so you can see the 2D image of your samples here. And I'll let it rotate 360 degrees to make sure it covers the screen. To make sure the whole part is on your screen. And the software we are using here is Datos X. And this scanning is set up at 80 kV and 220 microampere. And the number of images for the scanning we can set up here, which is 700 images. This means that the system will capture this sample in 700 images in 360 degrees. Okay, so this scanning can be done in just 3 minutes. And now I'll click start. And this samples is already start scanning. Although you see the sample like it doesn't move, but actually it rotates in a very, very slow motion to capture all the images. Okay, so once this is completed, we will then use our reconstruction workstation to reconstruct the 2D images into one CT volume. As Kent Hill Metrology, we offer a wide solution of measuring service like 2D and CT inspection system, which you can perform the non-destructive testing and internal inspection. That means that you don't need to cut off your samples for internal inspections. Okay, so now let's move to the workstation.
All right, thanks, QE. While waiting for the scan just now, QE did a scanning setup of about 3 minutes. While waiting for the scan to complete, let me show you something here. A short video while we wait for the scanning to complete. A short video talking about the capability of using X-ray CT onto your parts. Typically, whenever you have a part, you're going to have a drawing. A drawing is where you will define all the nominals, all the tolerances, and all the controls of your parts. So within here, you're going to set some dimension controls and the nominals. Then you start making prototypes. This is where you can put the parts into the machine for scanning initial trials. And during an X-ray CT scanning, the sample will rotate 360 degrees, like what my colleague just mentioned. During this rotation, software going to take all the images. And after the scanning is done, you can actually take out the parts, put it aside first. Use the software to go through a reconstruction process. This will compile all the 2D scan image into a 3D volume. So now you actually have a volume data. From this volume data, you can do all the dimension measurements according to the drawing. Everything includes all the GD&Ts and the dimensions, including diameters, radius, and so on. And if you have any CAD, you can import it, do a CAD overlay, and compare it. Green means within spec, blue means smaller than design, and red, normally you don't like it, bigger than design, out of spec. And also you can use wall thickness analysis to check on your draft angle to see whether the draft angle will cause the thickness of the wall to be too thin or too thick. And the next will be the most popular application, which is looking at the porosity without cutting the parts. So this is where it gets really, really interesting. Typically, whenever you have porosity issues or you have bubble issue, you have internal cracks, internal defects, as well as any internal defects. You have no other options other than cutting it for inspection. By using CT, you actually don't need to cut your part. From one scan data, you can do all the measurements. And then you can also do a CAD comparison, color mapping, and you can also do internal defect analysis like what we are seeing here. So these are some of the potentials of using CT on your parts. And just as we speak, the scanning is actually already done, the scanning that QE did. So now I would like to show you what happens whenever we do a CT reconstruction. So looking at the scan just now, this is the scanning that QE has done. During the scan, the sample will rotate 360 degrees. And this is exactly what happened just now. During the scan, the system actually captured all these images in a 360-degree rotation. And what we want to do now is we want to compile all these images. We want to let the software know that to convert them into a 3D volume. And we just need to click start, save it. And the reconstruction will normally take less than a few seconds. And now the software is prepping the data set and the reconstruction is underway. It's going to take you less than 10 seconds using our software. It's very, very fast. And you already have this reconstructed volume ready. And this is where it gets even more interesting. Let me open this scan data out. The loading time will take about probably another 15 seconds. So this is what happened just now. From the 3D scan, this is what you have. And I'd like to show you something where I already record a macro. Let's imagine this is one day we are doing a mass production. And the operator just need to come here and click play macro. And software will help us settle the rest. And this will take you probably about 40 seconds or maybe 45 seconds to be exact. And during this process, software is running through the macro to import all the measurement templates and do some CAD comparison and also do some wall thickness analysis. And I'll show you the results in a bit. And just look at the potential. From a scan that will take you about 3 minutes, you're going to have a full dimensional measurement results according to the drawing. You're going to have color mapping to show you whether there was any warping, bending or deformation on the part. Or you can even use the color map to decide how you want to correct your mold or how you want to correct your parts. Or you can even use the wall thickness analysis to look at how the draft angle affects the thickness of your part. So over here, this is already the results that we have. Just now I mentioned, right, 100% measurement according to the drawing. So these are all the dimensional measurements that we have done from the quick analysis just now that takes 40 seconds. So let me off all of it and let me show you one by one. So now these are all the measurement that has been done from the analysis just now. Green means all within spec. And if you want to see any out of spec NG measurements, look for red colors. Software will highlight it for you. Whenever you see a red color, this means NG. So you can zoom in, visually see what's going on. So over here, we have a part measurements at 0.5 degree, looking at the opening angle. If we just double click it, nominal is 1 degree. The given tolerance is plus minus 0.5. And this is exactly at the very near border range, so which is why it's NG. And we look at the rest, 2 out of 4 is giving an NG result. And let's look at some other potential where we have some GD&T measurements. Let's look at this flatness. The flatness of this area where the tolerated value is 0.1, but the measurement is around 0.09. That's why it's giving you a green color because it's within spec. It's okay. And let's look at this red color, what's going on with this. So true position measurements, normally very, very tricky to do. If you use some other machines where, especially if it involves some inner features and calling out datums to other surfaces. Typically for one measurements, you might need to cut a few places. But with CT, without cutting, we can actually see the results measured over here already. So for this true position, the tolerance is 0.1, but the actual value is 0.16, which is why software is telling us this is NG, red color. And looking at the other one, measured is 0.14, which is NG again. And let's look at the one that's green. This one is green because it's fitting just nicely at the tolerated value there, 0.1 as well. So it's okay, it's accepted. As for this one, it's out of spec again by about 20 microns. And these are so far all the measurements that we have done within the 3-minute scan and a 45-second analysis. Imagine today you want to qualify a mold, you want to do a first article inspection. Typically for a complex plastic parts, you're gonna have more than 200 dimensions that you want to measure. And I'm sure whenever you are coming from injection molding industries, you will know that for plastic parts, if you want to measure 200 dimensions, all of it, it will take you days, if not weeks. But for this one, you saw it just now. The scanning will take you just 3 minutes. The full measurement will be about 45 seconds. And other than all these measurements in dimensions, we also have this, what we call a color mapping. A color mapping is where you can use color map to show you the deviation of the part so that you can decide what actually goes wrong with the part if you want to qualify a mold. Let's say when you first design a mold, you want to qualify a part, but you want to see how do you correct the mold so that the parts get qualified. So from a color map, it will give you a very good idea where is the biggest deviations at. For example, over here, we are looking at some sinking over here in this area, the purple color. From the color map, color legends here, we are seeing Anything that's smaller than 0.15 range from the design, it will give you a purple color. And we can even see this visually. When I turn this off, the gray color here, this is your part. And you can see this area, you have a slight sink. And if you compare it to the cat, let's change this cat color to say yellow to make it more obvious. So now you can actually see what went wrong. So over here, you have a sinking. Your part actually sinks into the design. By about, you can even do some quick measurements. By about 200 microns, 0.2 mm. Which is why just now from the color map result, this area, it gives you purple because it's definitely going in smaller than 0.15. And other than this, we also have wall thickness analysis. Whenever you have a wall thickness concern in a certain area where if you want to fix a thickness, and this is where you can use this to help you out. So from this analysis, I given the software command to tell me where are the thickness of the part in the range of 0.8 mm to 1.25 mm. So software is mapping this out for me. By right, anything that's smaller than 0.9 or 0.89, it will give me red color. And luckily, over here on this part, we don't see any red, meaning the part thickness is acceptable, it's okay, it's not too thin. But then I also have an upper tolerance. I don't want the thickness to go too far beyond 1.2. So anything that's showing me blue color, those are the area where the thickness is going to be bigger than 1.2 mm. So over here, I'm seeing these two spots. These two blue spots is telling me this area, the thickness is bigger than 1.2 mm. So what can we do about this? If we want to further analyze this, we want to understand what's going on here, we can just use the software, map it, and find out that, okay, this thickness here is 1.21 mm. That's why it's blue. And what's happening? Why is this area thicker? And we can actually see what's inside. There's actually a bump. So this bump is where it could be an intended design, or it could be a defect. It's really up to the product owner to see what's going on. What we can do is we can provide you with all these images, all these results for you to better analyze your parts. And what's more, even more interestingly, is the defect analysis, which is shown on this new screen. Let me show it to you. So over here, you have the parts that we have scanned just now. And if I put in an analysis of porosity analysis or void analysis, so over here, visually, you can see there is one very big hole or a very big void inside the part, easily measuring about 1 mm. But then you can see these are just manual check. So I can actually use the software to run a porosity analysis for me. And software now will map it out for me, the diameter of this thing. So I can use the software, the analyzed data, just click, bring me to the biggest void. Software is now showing me this. Second biggest, third biggest, fourth, I can see. Or the other way, which is much, much easier, because we have a 3D data set. Let's look at everything from 3D perspective. And you can actually see now the voids are being mapped within the part. So these few colored, some looking like a bean shape, some looking like a sphere, some looking like a random carrot thingy. These are all the voids within your parts, where the software found that and it's actually mapping it out for you. So you don't have to do the work, let the software handle it for you. what you need to do is you can just use the software for analysis and to see how to improve the process. Also to see whether this will actually affect the stability of your part. Will it break during testing? If it doesn't, then probably you can just accept it because it's not a concern. Or if it's really bad until if you're facing a lot of issues where the part actually cracks, bends during a testing stage, then this is where you have to look into this and find out what happened inside your parts. And these are a few features that we can do from 3-minute scan. A very quick scan, and you have the results for dimensions, for color mapping, for wall thickness analysis, for internal defect analysis. And you can even combine all these features and to see how to improve your mold or do corrections onto your mold so that you can do the qualification faster. You can complete the article inspection faster. And this means you have a shorter time to mass produce it, to bring this part to the market.